Okay, so for this one, we're going to name ionic compounds and write their chemical formulas. So first thing we want to do is write the name. So the way you always name a metal and a non-metal together is the metal name goes first, and then you say the non-metal, and it's usually "ide." You have some polyatomic ions where it's going to be 8. So we'll go over that when we get there. So number 1, we have sodium, looking at the periodic table, and then we have fluorine. So what we would call this is sodium. The metal is just the normal name. And then fluoride. The chemical formula is going to be NaF. Now I have to figure out what these subscripts here are going to be, right? Is it a 1? Is it a 2? Is it a 3? Well, I want these charges to balance out. I want the +1 and the -1 to cancel out. So what I'm going to do is have these in a 1-to-1 ratio, right? 1 + 1 and 1 - 1. That cancels out to 0. I want these to be neutral, unless otherwise told that it's an ion, essentially. But these should be neutral. So this is NaF. And that's it. Next, we have K and S. This is potassium sulfide. Right, K for potassium, S for sulfide. Now, what do we do over here? Well, we need these charges to cancel out, right? So potassium is a +1 charge. Sulfur is a 2- charge. I need 2 potassiums and 1 sulfur, right? These charges have to cancel out. They have to be neutral. So I have 2 potassiums and 1 sulfur to get K2S, right? 2 +1s, and then 1, 2 minus, right? This is a charge of 0. So you want these charges to be 0. 3, it says you have nickel 2+ and SO4 2-. So SO4 2- is a polyatomic ion. This is our sulfate ion, so we know the name. So how would we name this? Now, if we have a transition metal like nickel that can take on different charges, right? I think there's a nickel +3 as well. We have to specify what charge of nickel it is. So the way we do that is, let me actually write out the name first. The way we do that is by putting a Roman numeral like that, or parentheses like that, and then a Roman numeral like that. So nickel 2, which means it has a +2 charge, sulfate. So this just indicates the charge of the transition metal, like nickel. Again, these charges have to equal each other, so this is NiSO4. Right, 1-to-1. Nickel's a 2+, sulfate's a 2-, 1-to-1 ratio. 4, we have aluminum and oxygen. So aluminum is always a 3+, so we don't have to worry. This is aluminum oxide. Now these have to be in a 1-to-1 ratio. So aluminum is a 3+ and oxygen is a 2-. How do I figure that out? If I have 2 aluminums, then I get to a +6, which doesn't even out with the oxygen. If I have 2 oxygens, then I have a 4-, and that doesn't equal out with 1 aluminum. So essentially what you have to do for this is find the least common multiple of 3 and 2. So the least common multiple of 3 and 2 is 6, right? And then we just have to get each of these to be a total charge of 6, plus and minus respectively, right? So aluminum to be a +6, right, in total, we need 2 of them. We need 2 aluminums to hit +6. For oxygens, we need 3 to hit a 6 minus, right? It has to equal out that aluminum. And then this is our formula. Right? You have to get these equal. And again, if you can't just multiply 1 by 2, right, like potassium, you just put in 2, you have to find the least common multiple. I mean, even for potassium, right, the least common multiple of 1 and 2 is 2. So you have to get potassium to 2, and the sulfur stays at 1, right, because it's already added 2. Right, and you can even double check your work, right? This is 2 times +3, that's +6. 3 times -2 is -6. All right, number 5, we have calcium, and then this is a chlorate ion, right? Chloride is just Cl, chlorate is ClO3, 1 minus. So we can name it. Calcium is always a +2, so we don't have to worry about anything. Calcium chlorate, and you can see this on the periodic table, right? The transition metals are in the middle, and then all the group 1 and the group 2 metals, right, are always going to be the same charge. So what is the formula here? This is going to be calcium, Ca, parentheses, ClO3, 2. Why? Why did I do this? Right, so the least common multiple of 2 and 1 is 2. Right, calcium's already at a 2, 2 plus, so I need this to be a 2 minus. So I have to take this whole thing and have 2 of them, right, kind of multiply it by 2. So I put this in parentheses, and then this 2 applies to everything over here. I can't just do Cl2O6, that changes the composition. So we do it like this. Parentheses ClO3 and parentheses 2. I have 2 of these whole things together in one calcium chlorate. 6, we have NH4 and then P3 minus. So NH4 is ammonium. Ammonia is NH3. This is ammonium. Right? This is our positive one, which is, again, kind of how we denote. Technically, it's not a metal here, right? But it's an ion. So you put the positive one first. Ammonium, and then phosphates, or phosphide, my bad. Right? Phosphate is something else. So phosphide, phosphorus just by itself. Similarly, right, we need 3 NH4s to balance out with 1 phosphorus charge, right? Because phosphorus is a 3 minus, NH4 is a 1 plus. Need 3 of them. 7, we have copper. Now copper is a transition metal, so we have to denote the charge, right, with the Roman numerals. We're going to put copper 1, and NO3 is nitrate. So that's the name, and we just put these in here. So CuNO3, right, 1-to-1 ratio. Next, we have copper 2 plus. So this is going to be copper 2. Got to denote that with the Roman numeral. Nitrate. Now, something to notice is that these Roman numerals don't put a space. It's copper, and then you put the parentheses right after. So I know it's finicky on Alex sometimes, but on the homework website. So don't put a space. Number 8 is going to be Cu, and then NO3, parentheses 2, right? Because it has to equal out. It's a -1 charge, and we have +2 charge on the copper. We need these to again equal out. Number 9, we have lead. Pb is lead. So lead 4, and we have oxygen, which is oxide. So we end up getting Pb, and this is O2. Right, 1 lead is a +4, oxygen is a 2 minus, so multiply it by 2. Ten is lithium. Lithium is always a +1, so we don't have to put the Roman numeral. It's in that group 1. Lithium carbonate. Right now we need 2 lithiums to balance out with the charge of the carbonate. Right? Lithium is a +1, carbonate is a 2 minus. So I need 2 +1s to balance out. All right, so that is it for this part. The name, the number of each ion in one molecule of that compound. So we'll write the ions here. And one, okay, so we're gonna write the ions here. I'll do the names at the very end. I suggest you pause the video and give this one a try yourself. No, I'm gonna continue on here. So first we have calcium. Actually, I'm just gonna do the names right now. This one is calcium iodide. Normal naming convention, metal, non-metal. We have calcium. Calcium is always a 2+, and iodine is always a 1-. Now, I have 2 iodines, so I'm going to have to put the 2 here. That's what it's saying by the number of each ion in one molecule. So I have 2 I minuses in this molecule, right? And this is to balance the charge. And you can also see the 2 over here. 12, we have sodium carbonate, NaCO3. So this gives me Na1+, right? And there's 2 of them. And then I have 1 CO3, 2-. How did I know it was a 2-? Because there's 2 sodiums, right? You can also check your polyatomic ion sheet on Canvas, but there's also 2 sodiums. Sodium is always a +1, so there's 2 of them. The carbonate therefore has to be a 2-, since there's 2 sodiums. 13, right? Now this one's a little harder. We have gallium chlorate. Now gallium is a transition metal, so how do we know which one it is? Right, well, chlorate, this polyatomic ion, is always the same charge. This is always a -1. I have 3 of them, right? So the total charge from this chlorate is -3, or 3-. That's how we usually write it. And gallium, I only have 1 of, has to match that, right? So this is going to be a gallium with a +3, right? 3+. So we're going to say that this is gallium 3 chlorate. And that's it for the name. Gallium is a 3+. As we said, there's 1. And then we have 3 chlorates at a 1- charge. CuF2, very similar, right? Copper can be multiple things. So let's check the fluorine. Fluorine is always going to be a 1-. How do I know? If you look at your periodic table, fluorine is in the second to last group. All the halogens are going to always be 1-. Oxygen will always be 2-. That's 1 over. Nitrogen will always be 3-. So you can kind of look at the periodic table and count back from the noble gases. So copper has a +2 charge here because fluorine is a -1. So there you go. Fluorine is a -1, copper is a +2 to match that. I gotta equal those charges. And so this ends up being copper 2 fluoride, right, where this is Cu2+, and then we have 2 fluorine 1- as ions. 15 NH4 3, and then PO4. So again, you get to know your polyatomic ions for this. This one, this NH4 is all together, and the PO4 is all together. NH4, as we said, is ammonium, and PO4 is phosphates. So SO4 is sulfates, PO4 is phosphate. We end up getting 3 NH4s at a +1 charge, right? As we saw on that other one, these are always going to be at a +1 charge. Phosphate is also always going to be at a 3- charge. Right? Always, no matter what. So all those polyatomic ions that you can see on your formula sheet on Canvas, those are always the same charge, right? They don't change like the transition metals. 16 is FeSO4. So SO4 has a 2- charge. If you look at that formula sheet, right, these are things that you can't really intuitively guess unless you have a background in organic chemistry. But you're just gonna have to look at the polyatomic ion sheet. So SO4 has a 2- charge. Therefore, iron has to have a 2+ charge. So this is going to be iron 2 sulfate. I have 1 iron up here, and then I have 1 SO4. 17, this is magnesium nitrate, right? Similar rules. Magnesium is always a +2, so I don't have to worry about the Roman numeral. And then we're kind of having the same things here. So magnesium is a 2+, and then nitrate is going to be a 1-, and we have 2 of them. NH4NO2. This is ammonium nitrate. NH4 is ammonium, nitrate is NO2. And then we end up getting 1 NH4 at a 1+, and 1 nitrate at a 1-. Next, this is potassium acetate. So this is, again, once again, you can look at the formula sheet for this polyatomic ion sheet. You'll get more familiar with these as we go along, and as you kind of practice. The most common ones you'll probably see are carbonates, chlorates, sulfates for sure, phosphates, and hydroxide when we start seeing that. Acetate, you don't really, it's not as common that you'll see. So potassium acetate is this acetate, if you didn't know, is going to, it's this whole thing, is going to have a charge of -1 because potassium has a charge of +1. Right? Potassium is always a +1. Therefore, acetate has to be a 1- or -1, right? We have 1 of each. Lastly, we have NaCrO7. This is sodium dichromate. So chromate and dichromate are 2 different things, so just kind of be careful. Cr2O7 is dichromate. Sodium is a +1, right? And then dichromate, if you weren't sure what it was, right, is a 2-, which we can get from the sodium, or you can look at the sheet. But again, if you don't know, you can use the sodium's charge to kind of deduce that, right? Because this has to be neutral. And that is it for this worksheet. So I will see you in the next worksheet, and I hope this helped.